Hi, I'm Richard, and in today's tutorial we're going to look at procedural terrain generation. So let's get started. Hello guys, and thank you for tuning in again. Today we're going to be looking at creating, I guess you would call procedural terrains. This is based on an algorithm called Perlin noise, and there's been a few tutorials around on the internet I've seen before, but I thought I'd take a stab at them because I found them a little confusing, and to be honest with you, it isn't the most straightforward thing in the world to do, but at the same time I think we can take a good go at it. There's a few things I'm going to try and do in this tutorial, but I think I might, if there's enough demand, I might actually try and improve on it. Perlin noise creates a very nice sort of wobbly looking feel like this, and you can adjust the stats to make this go higher and lower and more sharp. But it does very much create, if I can just go flat there, you can see very sort of, it never really deviates that much from the norm. So maybe we could have a think about how we can improve on this and perhaps create larger mountains in between these gaps here. So that's something to think about. But we need to draw this right back and start talking about how procedural meshes are created. Now, if I zoom right in, in fact, what I might actually do? What I might actually do is create a much smaller one. I'll say 16 by 16. I've got some stats over here in my script. Let's just do that. And if I doubt it'll be visible. There we go. What we need to do is we need to create some vertices. Well, in fact, we need to create 16 by 16, which is 256 vertices in this example. And what you do is, so each of these little points here is a vertices, and what you do then is you create these triangles, and these triangles dictate. Obviously, which way they don't dictate, but the direction that you create the triangles in dictates which way that specific UV will face. Okay, so you can see each part of these quads here is broken up into two triangles. All right, so the first thing we're going to need to do is get a new script going, a new scene going, and in fact we'll do a new project, shall we? Start completely clean and start thinking about how we're going to create this grid. We'll keep it flat. I know at the minute this is doing it in a Perlin noise kind of way. We'll keep it flat to start with, and we'll build on that. We'll make it move up and down. We'll also add a texture to it. Right. So let's get started with creating a brand new scene, shall we? So let's do File, New Project. I keep saying new scene. I mean new project. I've not been very well, you see. Okay, so let's call this Terrain Generator Tutorial. Click that. Let's not save that. I'm pretty happy that it was all pretty good before we started. Okay, there's the script that I've written already. I'm going to hide that away. You shouldn't be seeing that yet. That's much too much information. Don't panic. We'll build on that. It's not as scary as it first looks. Okay, so let's just initially think about how we're going to create our mesh. Let's create a script that's going to that we can define the width and height, and it will create that many vertices. So let's do that right now. Let's create a folder. In fact, let's create a folder. We'll call it scripts, and in that scripts folder we'll create a C# script, and we'll call that, what should we call that? We'll call that grid generator. And we'll double click it and go into monodevelop. If monodevelop's being kind, it'll come straight up. Brilliant. And here we go, we've got a nice clean mesh here. So we spoke about having a width and a height, public int width and public int height. Let's set these as usual with the caveat that let's keep it simple. Let's go for 32 by 32 just to prove that we can do these things. And I think we're going to have to say how far away we want them. So let's have public float grid spacing. Again, we'll just set that to something like 0.25 f, something like that, so quarter of a unit. Let's start with that and see how we get on. Let's add a new method down here. We'll call this void create grid, and in our start method we'll call create grid. Right, good. Now, in order for this to work, we don't just need to create a set of vertices. We need to store them in an array. In fact, we need to store them in an array of vector 3s. Now, one of the things I found difficult about UV grid generation is that it's quite hard to know how many vector 3s you're going to need. In fact, later on when you see we create the triangles, that can get very confusing. So what I like to do is actually create a list, a generic list, and the list actually lets you convert it to an array afterwards. It's slightly slower, but within the milliseconds we're talking here, so barely worth our effort now. We can always have a think about changing that later on to optimize it, but for now let's add the generic class. Generic. I hope I'm sounding okay. I've had a bit of a sore throat, but I think I'm over it. Okay, so in here we'll go list of type vector3. Let's call it vertices list equals new list of type vector3. Okay, and like I mentioned, Unity later on will want this actually as a vector3 array like that. Okay, and we can say vertices equals vertices list dot to array, and that will actually convert it to a standard Unity, standard C# array. Okay, so no generics involved. I like this method. Yeah, in Unity again, you don't store them in a sort of a multi-dimensional grid. You store them in a linear grid. Okay, so it is a little bit confusing. Okay, so what we can do now is just say for brackets int w, I guess, for the width is 0, w is less than width. W++, and we'll do the same for the height. We should probably call that depth actually. I'm going to call that depth, because the height, if you like, is the up and down. It's the y-axis, isn't it? This is going to be very flat, so this is going to be the x and the z axis. Okay, so we'll have that for int. You may disagree, in which case please use variables of your own choosing. D is less than depth. D++. D++ brackets doink. Right, and now what we can do is we can now say vector3 grid pos, something like that, equals new vector3 brackets. So it's going to be w, and then so the y is going to be 0 for now. 0f d. And also, of course, the fact that we've got this spacing, haven't we? So we just say w times grid spacing and d times grid spacing, and we can add that grid pos to our array. Vertices list dot add grid pos. This is good. Let's just see if this works. Let's bring in here. Let's no compiler errors. Let's just create in the assets. Let's create up here. Let's create an we can create an empty. Yeah, for now that's fine. And just double click in here. Grid game object and just drag our grid generator in there. Okay, looking good. Any errors? Vertices is assigned but it's never used. No, not yet, it isn't. Run that, and it looks like we're in good shape. There's no errors. Okay, good. One thing to check is, am I recording? Yes, I am. Good. Right. Nothing would make me sadder than to find out 5 minutes in that I'm not, well, I suppose to find out an hour in that I'm not recording, but at least I am recording, so we're all happy. Right. Sorry about this, guys. Now with that done, I think maybe what we could do is just to prove that that's all looking as it should. Let's just say here, instantiate. Yeah, do we need to do this? Or can we do debug dot draw? There's no. Oh, is it gizmos? Let's try gizmos. Dot. Except, yeah, this is going to work. Let's just try it. So that's going to be grid pos, comma, vector3. I don't know, vector3. Yeah, new vector3. Brackets 1, 1, 1, something like that. Let's just see if that works. And even if having it in gizmos enabled, this might not work. Let's just see. That doesn't work. But if we go to gizmos, I've turned that on. Let's go here, press F. No, that hasn't worked. Okay, but we think that it's drawn the vector3 positions here. I'm just to prove it. I am actually going to do this. So I'm going to add a. This is a bit unnecessary for now, but let's just add a game object. Public game object. What should we call it? Grid pos object. And then in here we'll just say instantiate grid pos object at the current grid pos with its quaternion.identity, which means whatever rotation it's meant to have. So we need to go back out here, create a small cube. Thank you. Just drag it out of that object. We'll make it 0.1. And then what we can do, I think, is if we just go here, we should have a new grid pos object. Let's just grab that cube in there. And now if we run it, be kind, but beautiful. There we go. And we can see that our vertices array has been created. Okay. Well, we can't see the array's been created, but you can see that we've been through this and created a width and depth grid. All right. Now comes the tricky part, and I think actually I'm quite glad that I did that, even though it may have seemed unnecessary. We need to think about how we're going to create these triangles to join these things up, and the way you need to do this, and there is some documentation already on this. I'm not going to put orthographic, there we go, just to show you. Can I zoom past it? There we go. The way we want to do this is we want to start at the 0, 0 position. Actually, let's just see where 0, 0 is. Is that one, and then that one. So okay, so we're going that way, are we? Hang on. That way, I think we are. Yeah, that looks right. So we're going to start here, and we want to go in a clockwise fashion. So we want to start there, actually, yes, and then we want to go to the one, if you like, the one below it, yeah. And actually, that looks like it's anti-clockwise. Now I'm going to split it this way just to make it clear. This way, because I know this works. We're going to start here, and then what we're going to do is we're going to go for the one above it. All right, so the row above. Then the one to the right and then back again. Okay, so we're going in a clockwise fashion. If we went anti-clockwise, the UV would face the other way. It would face downwards, which may be what you want, but for now we want it to face upwards, so we want to go clockwise. And then we also need to do another triangle starting here, and then to the one to the right, and then one down. Okay, and then we loop along the entire section. Okay, doing exactly the same thing. One above it. One next to it, and then the same one again. But we're going to want to stop one short. We don't want to go here and do that because there's no triangle to the right of it. So we'll go one short, and we'll do the same thing again. And let's just see how far we can get doing this. Okay, so next thing to do if we're going to take this on is we're going to take some big steps, and that is to add to our game object. We're going to have to add a mesh filter and a mesh renderer. So a mesh filter and a mesh renderer. I'm having trouble speaking. Mesh renderer, there we go, the two things we need there. Okay, so we've got those. Spin back to our script. So that's, if you don't know, the mesh filter is the mesh, and the mesh renderer is what allows us to show the mesh. Alright, we don't need to play too much with the mesh renderer, but we do need to play with the mesh filter. We do need a reference to the mesh renderer, because that, if you like, knows which mesh it's going to use here. Alright, okay, so let's go to up here, and we'll actually have an object. We'll just say mesh renderer, MR, and in here we'll say MR equals get component mesh renderer. If you're not following along, bear with me. That should make some sense very shortly. So we've got a reference to that. Now what we need to do next is say up here. So we'll say mesh M equals. No, we don't need to do that. Excuse me. We'll do that at the bottom here. Create a new one here. Sorry guys. Mesh equals new mesh. And then down here we'll say let's just get rid of that because it's after that anyway. Mesh renderer dot mesh. Hey, excuse me. Mesh renderer dot mesh. Where are you? What have I done wrong? Get mesh. I thought it was just mesh. Excuse me. Hey, where are you? Mesh renderer dot. Bear with me, guys. I'll have a quick look to see what's going on there. As you know, as I'm sure you realise, it's a mesh filter. Mesh filter. Let me just double check I'm not making that up. Mesh filter, yes. Excuse me. Ignore the mesh renderer is what displays it, but it's the mesh filter that contains the mesh. Sorry. So let's just quickly change that mesh filter. Okay, and we'll call it MF now. Sorry about that, people. MF, there we go. Sorry about that. No, why are you saying that? Maybe that's working. And then down here we'll say mf.mesh. That's it. Equals mesh. And I think you may have to do. No, let's see how far we get with that. Okay, this is good, but this isn't going to do anything. I don't think. It might do some. Yeah, so it has actually removed the mesh name there. Can you see that's good? Well, actually, let's just do this. Let's just say mesh.name equals terrain. Okay, and then if I've saved that, and if I run it again, there you go. We can see our thing here is called terrain. Guys, apologies, I'm just getting paranoid that I'm not recording. There we are, I am recording. There, so we've got a mesh called terrain. But again, we haven't done anything. We haven't done anything with this mesh. All we've done is create an array of vertices right now. We haven't assigned them to the mesh. In fact, we can do that though. We can do that right now. We can say mesh.vertices equals vertices, and that's the ones we just created. But we're not really there. All that's done is assign them. We need to get these triangles on the go. So let's grasp the nettle, so to speak. Let's use this same logic here. But like I say, remember that we need to go -1 because we're going to be moving one to the right, if you like. So we don't want to go to the last column. This is all completely wrong. And triangles, the way the triangles work is the triangles are an array of pointers to which vertices is the next one. Now, and this is where life gets confusing. So I'm going to have a list of type int triangles there we go. Triangles list equals new list of type int. Now, like I say, so we're going to start off with the triangles list dot that's right, triangles list dot add. We need to work out what index position each one is as well, don't we? That's annoying. So what we need to do is we need to say int current index, current grid index. Okay, so remember this is turned into a flat list here of arrays. So it would go, if I run this, maybe I should have picked a smaller number. But what was it, 32 by 32 we said, didn't we? So it goes 0 to 32, and then that one's next one is 33, 34, 35, 36. So we need to work out for any given W and D what our current index position is. So we're going to say current grid index equals, it's going to be depth equals brackets D times width. Okay, so the depth, yeah, well, it could be the other way around actually. Bear with me. Yes, I'm actually going to flip these around because I think I might be like confusing. So D, if you like, is the rows and W is the columns. So I'm going to make it do that. D is less than depth. Oh, what I could have done is just switch those two around, couldn't I? D++, but too late now. W, and then W is less than width. W++. That's probably why I was getting confused when I showed you those vertices earlier on as well. I was going around the wrong way. Okay, so D is the rows and W is the columns. So let's just do the same thing here. Yeah, I'm tempted just to go for it. Let's do that. Squiggle, squiggle. Like so. And now we can say, if I'm getting this right, current index position equals D times width plus W. Okay, so we're saying if for every row is int, so it's int there. Every row is that wide. So for row 0 it's going to, well, that's going to be 0, isn't it? But row 1 it's going to be starting at 32 plus W, and so on. So 32 to 63, and then 64 to 93, 2, 1. I don't know. You get the point. It's going to be going around and getting those index positions. Okay, so now we can create a triangle. All right, and I think we do this is we say triangles list dot add, and we'll just do one triangle for now. We won't do both. We won't do the quad, if you like. We'll just do one triangle and see how we get on. So we know it's current index, and then we need to go above it. So that's going to be current index list plus width, right? So a whole row across, and then finally, so we do that current index plus 1. So the one to the right of it. So let's just see how that works, and then what we need to do then, once that's all done, and we're happy that it's done all of those, we need to say int triangles equals dot to array. See, so that really takes away any worries we have to think about, what size is this triangles list going to be. But here we need to say mesh dot triangles equals triangles. Okay, let's just see if I'm missing anything. I might need to do a recalculate, but let's just see how we get on with that. Okay. Any errors? No. Let's run it and hope for the best. Okay, that hasn't worked, or either it's upside down. No, it's not there. Okay, well, let's quickly get rid of these instantiates now, because we know, well, I'm just going to do mf.mesh equals mesh, and I might just do a quick cheeky mesh dot recalculate normals to see if that helps. Let's just see if that helps. It does not. They just double check the size. There is nothing there. There's one curious cube there. Oh, that's the cube that I created. I can delete that now. Alright guys, I'll be right back. Guys, I'm sorry, I've realised the error of my ways, haven't I? I didn't put -1 on these, did I? I just copied them straight in there. Apologies if you were screaming at the screen there, saying, Rich, we know what you've done wrong. There we go. So now it's probably going to work now. So I was going array out index out of bounds issue because of it was going to, if you, I changed those. Let's just change it back to 32. I got it right down just to see the numbers. Often a good idea. Start right back at the basics. Let's give it a go now. See if that works. Here we go. There's a couple of problems. One is that it hasn't got a material. That doesn't bother me the slightest. But the other is that we're missing a triangle. But that looks good. Okay, let's do the other triangle now. If we just click on the game object, it's not letting us see the mesh. So let's just create the other triangle as well while we're at it. And that's going to be so it's going to start at the top. That one there. And remember, so now it's going to be that plus 1, and then that plus 1. I think. Let's try that. That's very quick. Yes. So top left, top left plus 1, and then bottom right of that square, if you like. Okay, let's give that a go. Glorious! What a good start! What a good start! Okay, this is a pink thing. It looks a bit weird. So let's create a stop it and create a material for it. Let's do that here. Just create a simple material for now. Let's do it. We'll just call it terrain, basic matte or something. Basic matte. Yeah. And then we'll just create a colour that's a bit of a grey colour, maybe just something to give it a bit of definition. Okay, and then if we go back to R, we can just drag that straight into there, can't we? Into the game object. There it is. Now if we run it, I think that will be fine. There's going to be some real problems with this later, but it looks fine for now. Okay, this is good, but it is extremely flat and extremely dull. So let's talk about that Perlin noise. That's why you came here, isn't it? That took a little while to create the mesh, but I think it was worth talking about why and how that worked. So in order to get Perlin noise working, what we need to do is we need to say, let's just quickly look at the Unity details on Perlin noise. Okay, here it is, and you can see that it gives this kind of somewhere value between 0 and 1 based on a given x and y position. It's got a very, very good example here of how you do that. So you can position yourself anywhere along if you like. The Perlin noise is if you just keep going x and y can go on forever. It doesn't matter, and it'll create this it'll have this sort of generic, random-looking sort of shades between white and black forever and ever. So you can pick a specific position. You should be able to guarantee that as long as you keep that position, it'll be the same mesh, same sort of height range in that section every single time. So we're going to do that. We're going to do exactly that. We're going to find that. But the thing that you need to bear in mind is that I think it repeats, if you like, between 0 and 1. So you need to break it down into very, very small decimal places, and I just need to remind myself how that works. Let's just have a play. Let's start with that now. Let's go into here and we'll just say, just typing this out now while I'm at it. So we're going to say, where's our vector 3 here? So we'll say float ypos equals mathf dot Perlin noise w comma d. Right, now I don't think this is going to work. I think all that's going to do is look exactly the same as it did before. especially if I don't change that to Y-pos. Okay, let's give that a go and just see how we get on. Okay, so we've got our sort of random places here. And it does, it looks exactly the same. If anything, I think all it does is just move it up to 1 point. So what we need to do is we need to if you like, break that down into a smaller chunk. So let's do that right now. So we'll have a value up here. We'll just call this Perlin scale up here. Public float Perlin scale equals I don't know, 0.1f, something like that. Make it small. Should it be above or below? Let's just have a play, and then we just need to say W divided by Perlin scale and D divided by Perlin scale. Okay, let's just give that a go. See how that looks. Still nothing. So bear with me. Let me just quickly remind myself what I need to do next. Apologies, that should be times by. That's where we're going wrong. Times there. Okay, Perlin scale there. Let's have a little look now. And there we go. We've got ourselves a much more what do you call that? Much more wobbly based system. Now I think now let's just play around with these values up here. We could almost, if you like, let's put this into the update method. Now earlier on this caused my system to crash, so let's just see if I can hopefully avoid that this time. Second, run that back here. Yeah, we're still going to do that. That's there. Let's just try and change that to 0.5, and you can see it gets much more spiky. And if we change that to 0.01, we get barely a nudge. 0.1 we know about, 0.2 it's a bit more rough, and so on. And obviously at the minute we're doing 32 by 32, so it's looking pretty jaggedy anyway. But if we were to up that to say 64 by 64, obviously it'll be a much bigger thing. So let's just make that 0.1. Have a much bigger range. And you see, here we go. We're starting to look at some really cool looking bumps. And we can, like I say, we can 0.05, just limit that down. So if you want to just sort of create a very smooth texture that was sort of walkable but not completely flat, you could perhaps go for 0.02. And even that's a bit too rubbish, isn't it? So 0. It's interesting, isn't it? What a difference it makes. 0.03. Okay, and potentially the other thing we could do, I suppose, is have a height factor. Public float height factor equals 1f. Let's save that for now. We'll just get rid of that, by the way. We don't need that anymore, do we? That was for testing. Let's have a look now. I'll click you. There you go. So you've got that. So potentially you could. Oh, hang on. We need to use the height factor, don't we? Times height factor. Might have to be a bit smarter about how I do that calculations. Height factor. There we go, and then run that again, and you get the idea now. We're just tweaking the values now. So now if I change that to 0.5, it gets smaller. So you've got the option there, 0.1. So you might find a value that you 0.3, and just tweak those until you find something that you're comfortable with. But like I say, I quite like the 0.2. There we go, something like that. You can see, you get the idea. This is good. That's actually rather good. It's always going to be the same unless we move it around. So what we can do is actually move this Perlin scale here. We'll add a value to that. Excuse my voice is getting very throaty. Let me have a quick drink. 1 second. Apologies. Okay, so let's do this. Let's also have a we'll call it a Perlin position. Public float Perlin position equals 1f. Okay, and then we can just go down here and we'll just say something like I'm just going to do something here. I'm just going to actually add a new value. I'm going to say float Perlin what should we call it? Perlin factor equals that times that. Okay, and then we need to add our new thing here, which is the Perlin position. Oh, sugar. Yeah, let's just space that. Perlin position plus those two. Right. And now we can just say that Perlin position and they're getting the same thing again. Okay. Sorry, Perlin factor. Excuse me. Perlin factor there and Perlin factor there. All right. So we've got the Perlin factor. I don't think that's going to break anything. Interesting. What did I do on this bit? Okay, so we see height factor 0.1. That seems a lot more busy there, doesn't it? Starting at 1 is an interesting place. Okay, so Perlin scale 0.01. That 1. It's gone extremely bumpy. I'm not sure why. Let's try to change the position to 5, 10, 100. Yeah, different places return different results. Okay, I just need to try and work out why that's suddenly gone so so angry. Just have a look at our little calculation here. Perlin position plus Perlin scale times height factor. And our Perlin scale is the same. 0.1. Okay, we can change these, can't we? 0 to 0.2. Yeah. A lot busier now, that's for sure. Seems to be getting a lot more in. I wonder if... No, I'm not sure why that's happening. But okay. I like what's happened. I actually quite like this. Height factor 0.1. That goes up when you do that, doesn't it? So we do 1 or 0.1. 0.01. Yeah, it's just about there now, isn't it? Interesting. Give me a moment. Let me just see if I can work out why that's happened. Okay, I've worked out what it is. It is the Perlin position that's affecting this. If I go back into here, because Perlin position is 1, it gets very, very spiky. The lower this value is, if I make it 0.1, it's a lot more understandable. If I make it 0, you end up with the kind of bumps we were having before. So you can do 0.01. So this isn't having the effect I was expecting, where it was going to move it around. It's rather, it just seems to be tightening it up. So let me take a look at that in a subsequent video. But for now, we're going to call it a day. In the next tutorial, what we're going to do is we'll add a mesh to this. Excuse me, add a material to this that's actually got a grassy surface on it, and then we'll start thinking about how we can create something a little bit. If I just flatten that out, that's too much. 0.2. How we can maybe create something a little bit more random, so that it's not just bumps everywhere, but perhaps a mountain here and a mountain there, and some gullies and things like that. So we'll have a little play around with that next time. But for now, thank you very, very much for watching. I can't speak tonight, guys. Much appreciated, and see you next time. Cheers now. Bye bye.